Hello world, it's Craig. I have a new project that you might be interested in, and possibly there's some more information out there that somebody can contribute. Make this go a lot quicker. Not too long ago I noticed this board on eBay. It's a Pro-Log PLS-881. You can see the number here on the end of the ejector. It was sitting on eBay with a starting bid of $7 or so, and then it was going to cost another $6 to ship. I looked it up in the Pro-Log catalog, and it's one of 4 8080 based boards that Pro-Log made. 2 of them, the 8811 and the 8821, were in the expandable, what they called processor card series. They have a 4-digit model number, and 2 of them, one of them is this 881 and the other is the 888, that were in the single board PLS series. And all of these were, earlier than the Pro-Log STD bus. So these are the cards that came out right before the STD bus was introduced and developed by Pro-Log. If we look in the 1976 catalog, of course 1976, to set the time, we were all concerned with the upcoming bicentennial celebration, the bicentennial quarters. We had the first look at the space shuttle and the Concorde, but Pro-Log was busy developing products because they came out with these 4 products in 1976. As an interesting side note, I lived near where they flight tested the Concorde prototype, and before it left the flight testing, they had an open house so the public could come up and see it, up and close and walk through it, and that was a very memorable experience. We also got to see the first 747 flight test several years earlier than that, which was quite memorable also. That Concorde, by the way, that was flight tested, is now on display at the Imperial War Museum in Duxford. And you can walk through it, and some 30 years after I first got to see it, I got to walk through it again. So that's well worth seeing. If you're in Duxford, go to the Imperial War Museum and walk through the prototype Concorde, just to see how small it really is. I mean, it's claustrophobic with those little tiny windows and little tiny aisle. At any rate, back to this. If we look at the catalog 1976, we see Pro-Log's first 8080 card. It's the 8811, which had 1K of RAM, but no ROM because it was meant to be part of that multi-card system. So provide ROM and I/O would be other cards in the rack. Pro-Log also offered the 8008 based 8111, and that came out, that was in 74. In 76, they introduced the Motorola 6800 based 8611. So in 1976, in their 8000 series, there were 3 8-bit processor cards. So 8008, 6800, and the 8811. There were no PLS single board computer cards yet introduced. They had PLS in the 4-bit, so the 8-bit ones were certainly on their way, just not in the January 76 catalog. They would come out later in 1976. As I mentioned in my video on Pro-Log's development of the STD bus, PLS stood for Programmed Logic Systems, and it was their effort to make microprocessor systems, starting with the 4004, PLS 401, make microprocessors seem less intimidating. So I also found online this 1976 new product blurb in Microcomputer Digest. It says they added the Pro-Log 8821, and the 8821 would be an expandable version like the 8811. If we look in the 77-78 catalog, we find the 8821 being offered. It's got 1K of RAM, 4K of ROM. Since it's part of the 8000 series, it had no I/O. But also in 76, they introduced the PLS 881, had 1K of RAM, 4K of ROM, was a single board computer with its own RAM, ROM, and I/O. The last catalog was January of 76. This is the 77-78 catalog. They have the PLS 881 as decreasing in price, so it must have come out in an earlier catalog that I just don't have or haven't seen. That's what this little down arrow indicates, that there was a price decrease. So you see this one has its price going down. These with the N are new product introductions. And back here, the price went up on a ribbon cable. So the rest of these with no notation, they weren't new products, they were existing products, and they were unchanged price-wise. So back to this card. In the catalog, there was an odd mention in this feature table. The first column is the PLS 881, and it says I/O expansion is via multiplexing. which seems like an odd thing to say. I hope it's not significant because I don't know what they're talking about. I did just find it an odd thing to mention. Multiplexed how? Because with some of the series, they did multiplexing off-board. So they would have control signals that would go off-board to a multiplexer somewhere else in the system. But since these were standalone cards, they might have signal processing beforehand or afterwards, maybe high voltage, input or output, and similar things, but I don't know if some of these control signals, if they did multiplexing off the card. So I don't know what they're talking about, but it's just something to keep in mind. Obviously, the data was multiplexed onto the CPU bus, but that would have been too obvious to state. I just don't know what they mean. So in the 7778 catalog was this new PLS-881 with 2K of RAM and 8K of ROM, so twice as much memory. Again, a single board computer. The PLS-881A made it in the 1979 catalog, but it must have come out sooner than that. The difference between the 888 and the 888A, the A isn't a separate revision, a later revision. The only difference is how the 2716 PROM was wired, and if it was configured for the Intel pinout or the TMS 2716 pinout. So the Intel 2716 and the TMS 2716 were different pinouts. For more background on the history of PROM pinout, take a look at video number 42, where this came up on the MIL-MOD 89 memory card. Back then PROMs had multiple and varying enable inputs depending on how they were ordered. So both the PLS-881 and the PLS-888 showed up in the 77 catalog, along with at that time the 8085, the Z80, the 6800 PLS single board computers. So it was a big year of product introducing for Pro-Log. And then by the 1981 catalog, STD bus was in full swing, and these cards do show up, but they're much later in the catalog. And very soon after this, they were announced that these were being phased out. But here's the PLS-881, the 888, and the 888A. So that was the end of Pro-Log introducing 8080 based cards. But since I enjoy working with 8080 based cards and that processor in general, I saw this on eBay, and at first I ignored it, but I thought, well, maybe I'll take a second look at it, make some amount of effort to rescue this card. But when I come across something like this, it's seemingly completely unwanted. The first thing I do is see if I have or if I can find any documentation on the board. That, a schematic is really nice. I don't need a user's manual, but at least if we had the schematic, that's a great fundamental starting point to understanding the board. But on this 881, all I had was this 2-page sales sheet. So a little technical document, really just a sales sheet, a little more than what's in their catalog. And this is all the information I had on it. I just had this and that little new product introduction that I mentioned earlier. So I spent a few evenings while watching TV with the missus, searching for additional documentation, but I found nothing that was really of useful. And especially I really searched for the schematics, couldn't find that. Now, by itself, non-existent documentation isn't the worst thing. I've reversed engineered cards before and got them running when I didn't have the schematic. That's certainly possible, but there's another nail in this coffin for this 881, and that is that when I bought this card, all of the chips had been completely stripped off. This thing was poached. There were no chips left. So I really, before I got this card, I had to consider, what are the chances of success getting this thing going, since not only need to create a reverse schematic, but we'd be doing so with little or no idea of what any of the chips are on this board. So I spent much of the remaining time before that auction ended trying to forget this little board. But eBay sends you that email that says, this is about to end. And so I got back on, I looked at it, and I just didn't have enough willpower. So I put in what I thought was a token bid, just to keep this thing out of the garbage. I had at least a clear conscience that I made the effort. I'd save it from the trash can or some gold scavenger. I mean, even the gold scavengers would be disappointed with this because all the chips were gone. The only thing left would be the fingers on this. The auction ended, and I wound up, getting this board for the $12 or $13. So here it is. The board's arrived. It's in pretty good condition, but the board with shipping. Now I got $20 into this thing, and I still don't know whether I'm going to be able to get it going. But now that I have it, I need to get serious about learning about this board. So I thought I'd, drag you along to see what documentation we can find. Maybe somebody's got useful input. Maybe somebody's got documentation, but even if we don't, it'll be an interesting project, and I'll show you some of my reverse engineering techniques. Not that I'm the best at reverse engineering, but it works for me. But since we have this card, we need to go back, figure some things out about it. So just from this 2-page spec sheet, let's see what we know. This was put out in April of '76, so that gives us a date as to when this at least was first introduced and when it was marketed. So the April of '76, that's several months before that introduction magazine article came out. Okay, so this is part of the PLS series, which we already knew, and fundamentally that makes it easier because it's a PLS. It can operate with just the memory and the things that are on board to itself. It doesn't need to go off card to fetch any instructions because it has all of its instructions in its proms up here. So that fact alone makes it that this is a simpler project than if it had been the 8821, which would have to go, well, actually the 8821 also had ROM. If it was the 8111 that had to bring all of the memory from off board, that would be a bigger effort, because then we would have to figure all of these buffers and transceivers and everything out just to get the card running, or just to get the processor running. On this one, all we really have to do is figure out how these are decoded and how the machine state status is decoded, because we need that for decoding these. But once we figure out how this is decoded, we can actually go out and fetch instructions once we get the clock running. So because this is the PLS, it's actually a simpler effort than if it were part of the processor only systems that require other cards to get going. On this, I think it's on the back, some other really useful information is this uses the 2102 RAM, so we know what all of these are. That's nice to know. And also it uses the 2708 proms. So we know what these are, we know what these 4 ROMs are, we know this is the 8080. Other than that, we don't know really anything about this card. We'll have to reverse engineer and figure everything else out. But that's some pretty good information. Other little tidbits on the front of this are, they've got a couple of diagrams here. This shows that it has 3 output ports, 2 input ports. So having 24 output bits and 16 input bits, that's a pretty respectable little single board computer for 1976. They give us the page addresses for the memory, and those will be useful when we're trying to figure out how it's decoded to know what the page address for all the memory are. And we can see that it's contiguous. The RAM is just bumped up against the bottom of the ROM. So a page, of course, is 256 byte block, and it represents the memory that can be completely addressed by 8 bits. And as far as I know, the 256 byte page came into existence with the 4004 processor, but I don't know for sure, and maybe it existed before that. But on the 4004, it was, pages were very important, because when you're writing in 4004 assembly, you can use an immediate data byte as an operand if you want to do a call or a direct jump to memory location that's in the same page. Or you could do an indirect if you used an 8-bit register pair to do it as an indirect jump. But if it's not on the same page, there was a lot more rigmarole and special techniques needed to take your program across page boundaries. You didn't just let the program increment to the next page boundary. You always wanted to jump to the next page. So pages were important back then, because a page is what 1702, the first EEPROM, 1702 held 1 page per EEPROM. So there were a lot of things that pages were important back then. But at any rate, these are the page addresses we have. Paging became less important with the 8008, because in the 8008 we had the HL register pair. There was still a little bit of important, because if you kept your code or something within a single page, then you didn't have to worry about what the H register was. You could always you could lose the H register. Remember, we didn't have a stack in the 8008, so registers were of critical value. And pages, they weren't quite as critical with the 8008. You could let your code just increment from across page boundaries. And then, of course, when the 8080 came out, we really we could forget about pages, for a while, because with the 8080 we had 16-bit register pairs, and so for the most part, pages became unimportant. So that was a diversion, but it is handy to know what the memory addressing is, because it'll help us figure out the decoders on this. And it is kind of interesting. They have the pages here in hex rather than octal, which I prefer hex rather than octal. But it's nice to know the addressing scheme. That's the long and the short of it. We've also got port addresses. So we've got port 0 and 1 and 0, 1 and 2. And these are hardware specific. So when you write to an output port, it goes out these chips and it's latched on one of these output ports. And then when you read that same port number, it comes in over here where it's, I don't know if these are latches or if these are just transceivers, but it comes in on this side. And then if you do a out of that same port, it goes out over there. Now, frankly, since everything's on board, I think it would have been easier to just memory map the ports and decode them along with the memory rather than I/O map those, because they've got 4, 5 counting the RAM, 6, 7, 8. So there's 8 blocks here, 8 1K blocks. They could have held out if they memory mapped these ports. Would have made the decoding a lot simpler. But it is possible, I suppose, they had some of their other systems that were I/O mapped, and so just for code compatibility, maybe they wanted to leave these as I/O mapped. But it seems though it would have been easier to just memory map these ports along with the rest of the memory and just use throw in one 74, 138 or whatever and decode the whole shebang at one time. This diagram does show up here. There's 5 control signals, and over here on the left there's an interrupt, a ready, and a reset input. So these inputs and the 5 control signals are just something to keep in mind when we identify, where they are and what they do. And I'm still wondering about this multiplexing, if some of these control signals that go off board have to do with the I/O multiplexing that they talk about. That's still just an odd thing to have mentioned. If we look at this little board layout, I'm not sure if there's any hints in here or not. They have the center 5 pins where they say input and output. The center 5 chips where they say input and output blocked out. So this is the I/O, and hopefully we don't have to figure anything out about those. There is one on this end, that one the 16 pin, and this one a 14 pin dip that are something else. Those are probably just glue logic. They're not part of the input and output block. One of the first things I'll do is go through and look at all the power and ground and see if these have standard 7400 type power and grounds, and no exotic power coming in, some oddball pins. So it's interesting, there doesn't seem to be any user configuration on this, so everybody was running their same system at the same memory location. There are some little jumpers here. Let's look at those closer. Here by the processor, see there's a little A, B, and C, either test pads or jumpers. Here's D right over here by the crystal, and then out here at the fingers there's E, and that looks like it's a bridged now, but that looks like a place that you can cut that trace and change something else. So there is a little bit of configuration on this board. Hopefully what those are will fall out when we're doing the reverse schematic. So on this, the clock is well marked, which is nice. It looks like Pro-Log used a clock chip on this rather than creating the clock from scratch on the Mill Mod 80 system that I have in an earlier video. So it's nice they used just a clock chip on this. And I'm guessing, I've seen this little combination before with the 8080, that this is a clock and this over here is a level shifter, an inverter, or something like that. So it shouldn't be too complicated for the clock. Now I would think that this guy back here in the corner is the decoder for the proms. Now if we look at some of the STD cards that came out later, this is where they would have a ribbon cable that would go off board. Some of the ports would come off a ribbon cable. But on this, I'm kind of thinking that maybe, because just by its location right here next to these proms and the RAM, that maybe this little chip up here is the decoder. If we look at the back of this thing, we really get some good information. What jumps out most is this lovely chart that gives us the edge connector pinout. And this is critical because when we're doing the reverse engineering on the schematic, we want signal names. Really, they're very valuable to have the signal names. So this gives us the signal names of all of the pins. We also know the signal names of the 8080. Since we know that these are 2708s, we know their signal names, we know the RAM, we know its signal names. So these are the only hard defined signal names. What we get off of this table, the processor, and the memory. But that'll be, when we're going down the line, this will be extremely critical to have these signal names. So, thanks to whoever put this table in, because, this table could be the make or break on this project, because it gives us so much information in the signal names. We can also see the 5 control lines down here. There is the interrupt acknowledge on pin 48, the wait on pin 50, reset on pin 52, reset complement on 53, and the clock on 51. So those are all 5. So when they were talking over here, these 5 control lines, and I guess now I see there's a little arrow there. These were actually all outputs. And none of these are for off-board multiplexing. So I don't think that multiplexer comment was, I don't think I need to worry too much about that multiplexing comment. It's still odd, but none of those off-board lines were to drive a multiplexer off-board. I think it's doing all of its multiplexing on board, just and directly going out through latches. Then here's the 3 input pins that were over here. There's the interrupt, the ready, and the reset. We know exactly where those are coming in. All of our power rails are given. So we've got our 5, our ground, our -5, and our 12. Down here we even have the power requirements. So yeah, this is without this little cut sheet, this would have been a tough nut to crack. The other things that are interesting here, this down here, this spare, it talks about this spare down here, where that's a reset, but they have in parentheses spare, and they also kind of expand on that a little bit here. So those were those jumpers I showed you earlier in that silk screen. So there can be a WO, which I presume is a write output. I'm not sure if that's memory or IO. There's oscillator. There's BDBin. Now DBin, of course, is the data byte in that the 8080 generates. The B, I presume it means it's an onboard. And then there's a B write. And those are all jumper selectable. So those must be those jumpers that I showed earlier, the A, B, C, D, E must be those jumpers. So the silk screen information, aligns with the data sheet. So that's a bit of a confidence builder. So while it's not nearly complete, this is more information than we would have had without it. So certainly valuable to have this data sheet. So if anybody's interested, I can send a copy of this data sheet. So now you know as much as I do about this board. We just have the data sheet, we've got that one new product introduction, and we have its catalog listing, which it just comes up over and over again. They've got the exact same stuff in all the catalog listings, so there's no real new information in the catalog listings. But now we're all starting from the same place. We've all got the same information on this board. Now this seems too easy, but in looking at what these chips are, let's see if there's any chance that we can see what these chips are if we look at it a little bit of a microscope. Here's that image. Okay, so this is in the catalog. And it's a halftone image, obviously. We can see the little dots. It's a halftone image. Okay, we can see that this is Motorola. That's an MC up there. These look like Signetics. Looks like an ST2369. I'm not sure what that number is. Of this clock, we can see that's an Intel. That's the Intel I they put on chips in the 70s. So that's a ceramic package with the big Intel I on it. So that's the Intel clock chip. That's good to know. This is a Motorola something. The RAM, we already know what they are. The ROMs here are all empty. And this is it would have been nice to be able to read that decoder, but I just can't quite make that out. In fact, if this image were just twice the size, If this were just published at twice the size, we would be able to figure this out. I did some more searching last night and I came across this advertisement, which is really useful. So this is an advertisement. They say this is the PLS-881 up here, and this is the 8821. So these are the two cards that came out that were listed in that 1976 new product introduction. The nice thing about this is in this advertisement, we can read these two chips here in the corner. One thing that is a bit odd is there's also two resistors here in this front corner, and my board doesn't have those two resistors. So I'm hoping that this actually is the 881, and it's not just something that they, a placeholder they put in for the photo. Maybe it was just an earlier version, because this is a Rev B, so it might have just been that this was an earlier version where they had these two resistors in the corner, because everything else looks the same. If we look, these are all 16-pin dips. That's a 14-pin, so that matches this. The second row matches. They're all 16s with a 14 on the end. That matches. The capacitors match. Little jumper down here at the end matches that jumper E. So I'm pretty sure this is the 881, and those two resistors must have just been eliminated on this. Also, this has the green solder mask, which came later than the blue. So my guess is that this was just a later revision. Those were eliminated. If we look, there's a couple of date codes on this I just noticed. On the front is a little date code down here in the corner, a 30 of 84, I think. So that's probably its manufacture date was week 30 of 1984. And on the back of the silk screen, there's another date code that is 21 of 83. So probably this revision came out in 1983, and then this board was made in 1984. I'm pretty sure that's a 4. I guess I can't read the 8, but I'm sure it's an 8, and I think that's a 4. So this came out, this board came out 8 years after the initial introduction of this board, and it's kind of funny that they were doing revision that late, because I think by 83 they had already announced that they were sunsetting these cards. So it's interesting that they were doing a revision of this board that late, because by then they were phasing everything out and replacing it with STD bus versions. In fact, I don't think they ever made an 8080 version of the STD bus, so these would have been the last of the 8080 cards. And the 8080 lived, or it was used much longer than it should have been, because it had some military kind of approvals or blessings that it was a safe chip to use, and so there were a lot of military stuff that continued to use the 8080 long after the Z80 and the 8085 and better chips came along. So the 8080 had a longer life than it really deserved in terms of its capabilities, simply because it had this approval for critical systems from NASA and the military and so forth. So maybe that's why they did this revision late on. Maybe they got a big order for these from somebody. So back to this chip. This is an MC7234. MC7234. That doesn't sound familiar to me at all. Let me look that chip up to see what that is. Okay, I found this online. In my catalog, they didn't list this. This was what's called a complex function. So here they had them listed as the 4000 series, but I found this online. It's the MTTL complex function. So it's a MLSI complex function chip, and we can see that the MC7234 is a 2-input 4-bit digital multiplexer. We can look at the diagram here. It's open collector. So you see it chooses between A and B. It has a couple of control bits. So I was excited when I found those in the photograph, but now I'm a little bit disappointed because this is fairly specialized. I'm not sure if there's an equivalent chip. Take some effort to find those things. But worst case, they're not so complicated that it can be recreated using just some surface mount 7400s. If we started with a 74-257 multiplexer and then did a invert open collector output, well, we might be able to get the same thing. But so that's just something to worry about in the future to see. I need to start searching to see if I can find some MC7234s. Okay, I also found, while I was looking for that, the same spec sheet that we had, the little 2-page cut sheet that we had for the 881, I found that for the 8821. So that was the other one in that new product introduction. That time it was just preliminary. What's the date on this? So the same month, 4 of 76, the 8821 was just preliminary, where this one was a done deal. But other than that, there's not a lot of information on this that crosses over. I was hoping for a little bit more off of this spec sheet that would help. But there isn't a lot of information that crosses over. And I couldn't find schematics for the 8821 either, so at least there was nothing to lead me too far astray. But the memory mapping is the same, and of course this doesn't have ports. It takes all the address and data off, the address lines and data lines off, but the memory decoding, it does have memory decoder here, uses the same chips for memory, so I was hoping to find just some more information on that. When I was looking for more information on that 881, I came across this 8821. So this is this one in this advertisement that we saw where we had that second cut sheet for it. So I couldn't see this real clearly in the photographs. I went ahead and bought it. And you see, this is exactly how this little hobby gets out of control. It's like rescuers going out on the ice, and more of them just fall into the lake. The next thing you know, I'll be importing a rail of obsolete chips purchased from some back alley chip broker in China. Or worse, I guess, I'll be purchasing the chips from the poacher that originally stole these things. So it's, like, well, here's $12 for the board and $100 if you please, and I'll sell you back the chips that I poached in the first place. Anyway, I got this 881 because it had all the chips, and now I can read them. And for the most part, you would expect that these would be very similar because they were designed essentially at the same time. This was designed first, and then this one was designed according to the preliminary on the cut sheet. But probably the same design team designed these. You can see from everything above the neck, these look exactly the same. Almost. There's a difference. This one has one chip up here at the top. This has two chips up here at the top. But just the fact that I can read all these chips, helped. And it gave me confidence because on this is indeed the Intel clock, and this is a CMOS inverter. So all of this is what I thought it was going to be. These are exactly the same. These are exactly the same. One thing that was funny is that these are not decoders up here on this. On this board, these are just buffers, just drivers of some kind. So, I'm now back to this. I'm not sure if this is going to be a decoder over in this corner or if this is just some kind of a driver for all of those, but that'll be easy enough to sort out. One thing to worry about on this 8821 board is this uses the Motorola 8T26A, I think it was. Yeah, it's the 8T26A. It's also marked as, I can't read the other number. It's got another Motorola number, but 8T26A. And it's not a 50-cent chip for sure, and I don't think there's a standard 7400 equivalent. So obviously Pro-Log was picking the most appropriate chip for the design and not worrying about the availability of chips 40 years later. But since the 881 doesn't put the address onto the bus, these are a transceiver. Since this doesn't put the address onto the bus, presumably none of these are going to be transceivers. Well, we know what these two are. They're not transceivers. So hopefully this 881 doesn't have those two 8T26As, which I don't think I'd ever used before. But probably that tells me it's time to go back when I'm trying to reverse engineer this and look at the Motorola catalog at that 8T series and whoever else made those, because they obviously were using chips that weren't just the standard straight 7400 simple chips. As I mentioned, it's curious that these are using the same RAM and the same ROM, and it's curious that these aren't decoders, these are just buffers. So we'll have to figure that out. But a lot of good information on this. And as I said, since this is the Intel 8224 clock and this is a 4049 level shifting inverter, unless I can prove otherwise, I'm going to say that they were the same on this. So essentially we figured out this clock part of it just by looking to see what they used on this, because this is the exact identical layout on both of these boards. Interesting little thing to note is, see, this is a red wire down here, just a jumper wire on this bottom corner. One thing that worried me about this diagram, or this photograph, I was worried that maybe this really wasn't the 881 because it had resistors down here in the corner, and my board doesn't have any resistors down there. But see, the same thing, in this advertisement, it has the resistors down here in the corner, and here it just has a jumper. So those were obviously, probably just a 0 ohm resistor, and so that got replaced on this board with just a little jumper wire. But this is obviously the one that's in that photograph because the resistor packs are identical. So that 0 ohm resistor was just a jumper wire. Pretty confident of that. And this up here, they must have just in the revision, they redesigned this, eliminated those, because this jumper on this one, you can see it's just that the finger voltages, the power rails on the fingers just didn't match what was convenient on the board. So they jumpered the minus, I think that's the -5. They jumpered it over the other two. And by the time they did this revision, they just eliminated that. They just had to swap those two back and forth. And that's kind of like, when you're driving, leaving California north, going into Oregon, there's a little part where I-5 where the lanes switch sides. And it's really kind of odd when, you're driving down the road and all of a sudden the oncoming traffic is over towards your right instead of on the left-hand side where they should be. So I'm not worried about those jumpers not being there anymore. They just eliminated that in that revision. So high confidence that this is in fact the 881. Disappointed that those are more exotic chips, but I suppose it's better to know that they're exotic chips than not know what they are, because I never would have guessed. I never would have come up with those 7234s no matter how long I looked at this. So here's the plan. I need to clean this board up a bit because there's some corrosion on some of these chips, and whatever caused the corrosion on this really made it so that some of there's corrosion on this socket, whatever caused that corrosion made it so that some of these chips were hard to get out, because when the gorilla yanked these chips out, he damaged a number of these sockets. In fact, if we look at this one down here in the corner, they tore the leg off. You see the leg is still sitting in the socket. So unfortunately, certainly that chip went into the garbage can after all, and I wish they had done me the favor of putting it back in so we knew for sure what it was, but it's too late for that. So I'm going to ignore as much of the circuit down here as I possibly can, just get the top half of this board working. Since this doesn't have to go off board to fetch instructions, that should be pretty straightforward to get this going. All I really need is a clock. Once I get the good clock going, I need to make sure that the reset and the interrupt requests, so forth, the signals coming into this are all at the right values so that this 8080 will actually start going. And at that point, it should go out and start fetching instructions. And so then I just need to know a little bit about the decoding of this PROM. And hopefully that's as simple as a 138 or some kind of simple decoder like that. Let me go back and look at some of these chips and see what they are, because there is not a 74138 on this. Let me see what they were using to decode this. Okay, so on this, there is no 74138. There's 74367, which is a buffer. There's 74175s, which are flip-flops. And then there's the decoders are the 7442s. There's a pair of them here. And the 7442, it's a BCD to decimal decoder. And so a 1 of 10 decoder, and they've got 2 of them on this. So if 74138 doesn't fit that, if that's the decoder and 74138 doesn't fit it, looks like a 7442 was maybe their favorite decoding technique. So in the next video, I will show you my technique for doing, kind of the worst case, no absolutely nothing reverse schematic capture. So as I was saying, to get this board going as soon as possible, going to focus on everything from the neck up. I'll be able to work backwards, from the 2708s, pin 20 is the chip enable on that, be able to find out fairly easily which is the decoding chip for that. We know that the RAM is just the next 1K block above the PROM, so that should all be fairly simple to decode. Most likely it's the 7442 decoder, just like they used on that one. From the 8080, that will have the strobe signal that comes out for the machine state latch, which we need to know because that separates whether this is a memory read or a memory write or a port IO read or write. So we'll need to find those latches on this. So there is one chip down here that's probably that latch, which we will need to find. It would have been so much easier if they just, since they used the support chip clock, it would have been so much nicer if they used the 8212 status latch chip, because that would have stuck out like a sore thumb on that because it's a 24-pin dip, and that would have been an obvious choice. Now I'm gonna have to dig down here and find out how they were latching those signals. But it shouldn't be too bad because we've got the strobe that will come out of this clock to latch it, and then we've got the data bits, the data bus that will come off of the 8080 that will go to that latch where it gets the strobe from, or it gets the status bits from. So somewhere those will all come together down here on one of these chips, and that's going to be the latch. So hopefully I can find out what that latch is, get this thing fetching instructions, before I become too frustrated with the whole project. When doing this memory decoding, I can expect that the memory is wrapped around and will be decoded at multiple locations because the only memory that this can access is this memory that's on the board, so there would have been no reason to worry about wraparound memory. But since the I/O is I/O mapped, there's also decoding for the I/O on this. So maybe a couple of these are 7442s, just like on this one to do the decoding. Just have to see how that's done. I guess I'm just talking aloud that I have to figure out where that status latch is, because since the I/O is I/O mapped and this is memory mapped, there's no way that you could have the two on these without knowing what those status bits are. So I'm pretty sure I have got to figure out that status bits. I was looking for a shortcut, but I don't think I can ignore that. So I'll work on that and report back in a later video after I've done some tracing and I've started capturing out the schematic. And once I have the schematic started, I document things as I find them. And then as soon as I get this thing to fetch instructions, then the next thing is I'll hang a serial port on one of the EEPROM sockets so I can start running some test code in this, a little toolbox to help diagnose and investigate the rest of this board. Because once I get a serial port, then I can connect this to a terminal and I have I/O. I can give my program commands. I can tell it to go out and look at certain addresses or for certain things, and then I can look at its response. So all I've got to do is get this guy to fetch instructions. I don't need any RAM. I can write a lot of code with no RAM. So I really just need those control signals, the clock, and instruction fetches. Hang a serial port on this so I can do I/O to it, control my code, and then all of this down here should get a lot easier once I have code running on this. So in the next video, when I start to get that thing pulled together, we'll come back and revisit this, and we'll look to see what my progress is. So let me go off and get it to that point where I can at least communicate on with a serial port in one of those RAM sockets. So obviously this video is a call for any documentation regarding this board, which would save me some effort here. So if anybody has a Pro-Log PLS-881, can send a photo that has what the chips are, that would save quite a bit of work. And of course, if you've got the schematic, then that will be the have all and be all except for the user's manual. So if you got schematic or the user's manual, if somebody can send me that, then I'll return the favor by sending you a Pro-Log STD bus card or an Intel ISBC or something like that. Something that I'm not using. I have an extra. If somebody can send me the schematics, the user's manual for this, then I'll send them a single board computer in return. Okay, well, thanks for watching. As always, these videos are fueled by likes and feedback, encouraging comments, and subscribers. So I will talk with you later.